Yeah, what's up internet? Synth Media here, and this is my original trusty Kawai K1 keyboard. It's the first real sort of digital synthesizer I've bought. In fact, it's the only real hardware synthesizer I've ever owned. Certainly the only sort of keyboard, and this was like my original basis of my studio. I bought this in the late 80s when I first got a job and got some money. And it was basically this with a 4-track cassette recorder. And I'm just kind of digging it out because, well, I'm going to show you in a minute what I'm going to do with it. But let's just hear it. The sounds, this was like a kind of, I suppose you could say, a sort of cheaper equivalent of something like a Roland D series linear arithmetic type synthesizer. It's basically got an attack, which is a sampled waveform, and then a synthesized decay. So they kind of just had a small amount of ROM with these realistic sounding attacks, and then synthesize the rest of the voice. So here is the classic preset from this, the kind of choral R sound. And kind of I got this partly at the time I was interested in the idea of making more exotic ethnic sounding music, so I was very taken with this kind of sitar sound. And I think there was a panpipe. Yeah, here we go. So yeah, you can hear that like an attack is a little bit more like a real instrument, but then it's a synthesized sound behind the scenes. So yeah, so this was my first keyboard, and the reason I've got it out, I haven't used it a lot for a long time, is that now it's hooked up to MIDI. It's going down this cable here, MIDI connection, slightly precarious audio connection, into my Focusrite interface, and then into my computer. And we're going to go to the computer now. Okay, so I'm now back on my computer, and here's what we're going to do today. I've got that old K1 out because there are some sounds on it that I would like to sample. And what you can see here is I've got FL Studio loaded up with DecentSampler, which is a free VST by this guy here.
Hi, I'm Dave Hilowitz.
Dave Hilowitz. He seems to be a developer as well as a music YouTuber, so obviously a great inspiration. And he's come out with this DecentSampler. It's quite a nice free sample player, like Direct Wave in FL Studio or Contact or something like that. And you can make your own sample-based instruments for it. Kind of looking through this, I decided that this was a fairly easy format to work with, and because in fact I had some problems with Direct Wave in FL Studio, and obviously because this is a VST, this is applicable to people using other DAWs as well. It's not just FL Studio based. So that's what we're going to do today. We're going to take that Kawai K1 and we are now going to sample it. So to make a sampled instrument, you're going to need to take a certain number of examples of notes here, maybe every octave or every 3 notes, record them into sound files, cut them up, load them into the DecentSampler and create a metadata file format. I'm lazy, I'm not going to do all that by hand. So what this video is really going to be about today is this. This is my SampleRobot program. I've written this in processing. It took me a couple of days to write this. It's quite short, and most of this video I'm going to explaining how it works. It's using processing with a couple of standard libraries, this minim library and the MIDI bus library. So the MIDI bus lets us send out MIDI notes, and the minim library is an audio library that includes lets us actually record the sample. So what this program is going to do, it's going to send MIDI messages out to the keyboard to play a sequence of notes. Every one of those notes it's going to record in a separate file, and then we will continue to do a bit more processing. We'll also generate our text file. It's an XML file, in fact, which is suitable for putting the sounds into Decent Sampler. So I'm going to run this program now, and we are going to sample one of the instruments. I'm not a great sound designer. I certainly wasn't a great sound designer on that keyboard. I mean, it had its own vibe and its own charms. I don't think anyone would claim it's a great synthesizer. Certainly wasn't very easy to program, as far as I could tell. But it made some characteristic sounds. So we're going to sample one I called Manga, which is a slightly detuned hollow bell type sound. And then I'm going to show you how I make that into an instrument. So the first thing is I'm just going to run this program. You can hear it grabbing the notes. I will then make the instrument. I will then explain how the program works. Okay, so the program has now done its job, and if we look in this directory here, you'll see it has created a number of sound files for each of those notes. Now those are not immediately usable. They're stereo files. I don't know about Decent Sampler, but when I was trying to get them into Direct Wave, I needed mono files, it seemed. So the next thing I did was I got Audacity. Audacity is another free software audio editor, bit like Edison but independent of Adore. You can use it by itself, but the useful thing is it has macros that let you do batch processing. So I've got a macro called FixRobot here. What that's going to do, this has been set up to firstly do a stereo to mono transformation. It's going to take that stereo file we recorded and turn it back into a mono file. It then is going to run truncate silence. That's going to chop. There's a little bit of silence on the front of these sounds when they get recorded. We're going to chop that off, and then we're going to export it as a WAV. So if I go to files here and I now choose that range of files we just generated, I click open. At this point, the batch processing from Audacity is taking place, and what you can see now is it's created a new directory here called macro output that contains all of those transformed sound files. I'm now going to take this Manga DS preset, move it into there, and I'm going to rename that Okay, so here's the file that I generated from inside my program as well. It's an XML file. in a format that is suitable for loading into Decent Sampler. So the basic idea here is that you have, okay, it's an XML format. You have these sort of tags wrapped around things. It's a bit like HTML if you've heard of that. If you know what XML is, this is self-explanatory. If you don't, just consider it's a sort of text way of telling a program some configuration data or some sort of extra information. So this defines a simple instrument. We've said here, in this sampler, we've got a number of groups. There's only one group here. A group is a number of samples. The sample was sampled as a root note. This is the MIDI note here. The file name for that is this. That's going to be used. In fact, what I do here is each of these samples is going to be spread across a small range of about 3 notes. I actually do something slightly strange. I actually use, say for something that was sampled at note 39, I use it between notes 36 and 38. That's a little bit odd. I saw somebody saying that on the whole it was better to take samples and pitch them down rather than take samples and pitch them up. So I decided that the sound quality just is a little bit nicer in a slightly gritty lo-fi way. If you use the sounds, if you play them for the whatever you've sampled them at, if you play them at a little bit lower, so the MIDI notes are these. Now, in some other samplers, it can deduce which notes you're playing just from the name of the file. I had a huge trouble trying to get this into Direct Wave. Direct Wave doesn't seem to want to map these correctly, and I still haven't worked out why yet. So if I find that out, I'll show you that in another video. But in Decent Sampler, it now seems to work pretty well. So let's now go and load that file in. Here is that file we generated, Manga DS preset. And as you can see, it's now mapped those sounds across this. However, they've come out very quietly, so we're going to put the volume up here. Alright, let's try and do something interesting with this. Give myself a couple of bars. Just choosing randomly here. Yeah, I like the more. But I will have kick words. I write weird music. Sorry guys. Where do we go from here? Okay, warp brass. This was another. Pump you up. It's a little bit of wave shaping. Kind of obnoxious sound, but all to the good. Touch of reverb, maybe. Well, I'm kind of liking the way that's developing now, but it must be said, it's a bit weird, and it is... so these are all K1 samples, though. They've all come in through that SampleRobot. So I'm going to leave this piece here. I may return to it later on and show you a final track, or bit of a track. But let's talk about the code. Okay, so let's start having a look at the code here. And I want to be clear before we start that this is obviously not an introduction to processing or to Java. I'm hoping that you will have seen both processing and Java before, but if you haven't, then perhaps if you know enough of some other programming system, this should still be fairly clear how this works. But I have been thinking about whether to do a more basic processing introduction. If you'd like to see one of those, then I'm very happy to do one. Just leave a comment, and if enough of you like the idea, then I'll do one. But at the moment, I'm going to assume that you know enough programming just to follow along here. So what is the task? The program is going to play a sequence of notes on an external MIDI device, keyboard, synthesizer. In our case, we're using that Kawai K1. And then we are going to record each of those in a separate file, and we are going to generate this configuration file that refers to each of those files we've saved, what the note they were recorded at and the notes they should be used at, and Decent Sampler will be able to use that to create a Decent Sampler instrument. So that's the job here. Now what this is going to do, this is going to go through each of those. But to record a note, a single note, there are a number of steps, or there's a sort of timeline. I'm going to show you the timeline now, right? So this is the typical cycle of a single note being recorded. We start, there's a start time now, we start with the recorder off, a bit later we send a note on message, a bit after that we send the note off message, finally we stop recording. So this is a typical cycle through one note. Of course, then we go around and we do the next one. We leave a little bit of a gap before we start because we don't want to kind of overload processing. You know, processing is Java. It's got a virtual machine. It's doing a bit of housekeeping, garbage collection behind the scenes. We're not trying to do this as fast as possible, so I explicitly leave a bit of a gap between each cycle. But as I say, at the beginning of the cycle there's a small gap before we start the recording. Once we've started the recording, we leave a little bit longer, and then we send the note on message via MIDI. During this period here, we're effectively holding down the key on the keyboard, so we're getting the attack, decay, falling to the sustain of that envelope. Then here we take the note off, we send the note off message, so we've taken our finger off the keyboard. We're now just letting the release die away, and then we stop the recorder, and then we go round again. So that's the cycle, and of course we're going to repeat that for every note in our series of notes. So here I've got a definition of this class. I've got 3 tabs up here in the project. I will try and make this project available to you, so you can actually download it, play with it, use it yourselves, and obviously make any changes you'd like to change. But the format is these 3 tabs here. We've got the sort of main code here, the definition of the SampleRobot that does most of the work, and this object called the DecentBuilder is the object that creates that configuration file for Decent Sampler. So firstly, inside the SampleRobot, we actually have an audio recorder. That's the class that comes from the Minim library. That's how processing knows how to deal with audio or recording audio. We have a string which is the name root. So if, say, like we're recording the manga instrument, I just called it manga. Then we have some parameters sort of general parameters initially for the robot volume, what's what the velocity we're going to be sending our note on message at. So we could in fact run this several times to record banks of quieter and louder from the same instrument. In this case I'm not doing that, and I haven't automated the looping through that, but that would be fairly straightforward to add. The start note here is when we're starting from the bottom, what's the note we're going to start at? We'll maybe start at typically octave 3 or something like that. The current note, that's just remembering what note we're currently playing. The stop note, what's the highest note to the top of that sequence? And then the step between notes. We won't necessarily record every note on the keyboard. We may record every third note or only once an octave. Depends what we want, but that's defined by this step variable here. So this next collection of variables here are the parameters that are controlling or tracking and the variables that are tracking this cycle here. So the note down length, that's a parameter between how long we're going to hold the note down. In other words, this time between sending the note on and sending the note off. The sample length is actually how long we're going to record from between sending the note on and stopping recording. Obviously the recording started a little bit earlier, but we will trim that off later with that Audacity thing. The start time is capturing the time when we start recording. So in other words, we are going to ask, just as we start the recording itself, we're going to grab the absolute time in milliseconds, the note on time. Based on that and based on some of these earlier parameters, we're going to calculate the note on time, so exactly the time we're going to send this note on message. That's in note on time. Note off time is going to be calculated as what's the time we're going to send the note off message. So we knew the lengths of these two, but it's only when we actually start recording and we capture what the current time is in milliseconds that we can calculate the time in milliseconds when we want to send the note on, send the note off and stop recording. And so that's what these three variables are here: note on time, note off time, stop record time. There's a gap flag that's just used to kind of help us set a little bit of a gap between there. And there's a started flag, which is we don't want to keep on sending the note on, it's a sort of latch. Once we've sent this note on one time, we don't want to send it again. So that flag just records that. Come down here, a bit more important information: the MIDI bus, the note names. This is used for generating these note names in the file names here. There are some samplers which can deduce the notes based on these names. In principle, FL Studio's Direct Wave does that. I've had problems because when I generate these files, it's not able to map these files directly based on just the name. I'm not quite sure why that is. If I solve that problem, I will tell you in another video. But that's in fact one of the reasons I decided to use DecentSampler, because DecentSampler you did all explicitly using this XML file, and that's working for me. And also, of course, you don't have to be using FL Studio. If you're in a different DAW, DecentSampler should work fine. So we're going to use these to build the names. DecentBuilder is this class over here that's going to build that DecentSampler file. It's very convenient, it works for me. But if you have a different sampler, then perhaps you will be able to make it work just by giving these the right names. So we're just going to initialize the SampleRobot name root, the velocity, the start note, the number of octaves that we'd like to capture. Maybe we want to capture 5 octaves starting at MIDI note 32 or something. From that we're going to calculate the stop note here. Number of step length, so how many steps up do we go, or in fact half steps, these are semitones. The NDL and is the note down length. In other words, how long we are keeping the note held down, and the sample length, how long we are going to be recording for. So those are the parameters that are being sent to the constructor for our SampleRobot. They're just going into the variables as I described previously. We create the bus. At this point, you'll notice that creating the MIDI bus, I had to give it this parameter. This string is very important. It's the name on my machine that the USB MIDI interface is called, and you'll notice there's an extra space at the end there. When you first run a program using the MIDI bus, it's a good idea to do this, to run this command MIDI bus list. It will print the buses, it will print the MIDI devices it can see connected. From that you'll find out what your interface is, grab that name, and that should go in here when you create the MIDI bus object. There's a method here called file name. That's simply the way of generating, based on the current note we're playing and some of the other pieces of information already in the robot, that will generate, say in this case, manga_A3_60.wav. So now, to understand this cycle, I hope that's clear, but what's important to realize is that processing is a system designed to kind of have an animation or something running. So the standard shape of a processing sketch, as you can see here, is it's got a setup phase which runs just once at the beginning of the sketch. That does all your initializations. And then it's got what's called draw. Now this is a method that is called 30 times a second or something like that. It's just doing some regular thing. So anything we do has to happen. Okay, my robot is called Robbie. So the way I've got this working is this draw is being called by, if you like, the rendering, the graphical thread that is drawing on the screen. I have a method called step. Step is therefore being called 30 times a second roughly, and inside that regular call we have to navigate through these different steps and do the right thing at the right time. So most of the code going forward and most of the complexity we're going to see is what we have to do at different times during this cycle and how those are initiated and the sort of flags and variables that are set between one and the next. So let's say we're starting a new recording at this point here. Well, the first thing we do, we're actually going to create a new instance of, we've got the library, the minim library recorder. We're now going to create a new instance of a recorder. And if you notice, the recorder, when we set this up initially in the main, we also from the minim library we have a variable called in, which is the audio input object. We created a new minim. We used getLine in. We told it was going to be a mono input from the in this case from my microphone or my interface. Put that into this variable called in. Over here in the SampleRobot, I'm using that to create a new recorder which is recording from this input channel, and it's recording to a file, and it's at the point we create it, we actually give it the file name to record into. So if you remember, I'm using this file name just to create that. So at the beginning of a new cycle, current note has got the current note we're going to play. I generate the appropriate name, which is of this form here, using this method called file name. And here I'm actually creating. Now there's going to be a certain amount of time it takes to do that. So I do that first, then I grab start time. So the start time here, when we're starting the recording. So I now know what time It currently is in stardom. Now I'm going to calculate these, the send note on time, the send note off time, and the stop recording time. So the note on time is start time plus before play. That's just this little gap here. Again, I'm leaving a little gap because suppose when I create this minim recorder, there is some background process still going on to open that file, right? I don't want to immediately send my MIDI note out just in case the MIDI note on is getting to the keyboard and it's starting to generate its sound before the recorder is really open. You know, I'm not sure if that's kind of happening in a different thread. So just to be on the safe side, I've got this before play here. It's only 10 milliseconds, but I'm just giving it that extra bit of a space before I'm going to send the note on message. Note off time is note on time plus the note down length. In other words, that's how long we're going to hold this down. So we've calculated that, we measured that, we've calculated send note on, we're now calculating the note off time, and the same with the stop record time, which is this. So now at this point we know what the current time is and we know what times we're going to do the sending the note on, the sending the note off, and the stopping the recording. We set the started flag as false because we haven't sent our note on yet, and record we said start doing your record, begin your recording. So that's the start next behavior. Okay, now step, if you remember, step is the thing that is being called every re-rendering of the frame, which is about, frame rate is about 30 times a second. It can actually be set to be higher in processing. Perhaps in future versions of processing it will be higher. So I'm not doing very much counting in terms of frames. I'm tending to be counting in milliseconds. But when we run that step, we're in one of two phases. Are we currently recording or are we currently not recording? If we're currently recording, we're going to do the recording step, and if not, we're going to do the non-recording step. Now, the is recording test is simply the recorder itself. Remember we started here, has its own flag saying, are you currently recording? Is recording here. Make sure that the recorder has actually been initialized. We need to write this code defensively, right? There is a possibility the recorder didn't get constructed at the point we get this method, so if it hasn't, we're not recording, return false. Otherwise, we just ask the recorder itself, are you recording or not? That's being used up here during every step. So if we're recording now, we do the recording step. If we're not, we do the non-recording step. So if we're in the recording step, we're going to draw on the screen currently recording and the file name. We know, remember, the current note contains our current note. We're now going to grab the current time in milliseconds. This millis function comes with processing. It's just getting us the current time. You saw it being used up here as well. We could obviously now use the current time. We already knew when we were starting the recording. We'll use our current time to work out if we should be doing any of these other events. So if the current time is greater than note on time, so if we've got past here in terms of time, and our started flag is false, as if you remember we set it to up here, so we hadn't sent the note on yet. So in other words, if we've got to this point in time and we haven't sent the note on message yet, then we're going to do that. So we're going to add to our DecentBuilder. Our DecentBuilder, remember, is going to construct this. We're going to add sample line. That's basically a way of telling it to record another of these lines in the file for obviously the current note. That's what this line does. And then we're going to do bus, that's the MIDI bus. Remember, send note on, that's built into the MIDI bus. Channel 0, the current note, volume. Volume is in fact the velocity. It's usually volume, it's how hard the key is being hit. And we set the started flag to true. The first time, in other words, our time has passed this send note on moment, is when we send our note on. After that, our flag is true, so we don't want to send that note on again. If we kept on sending our note, it would be stuttering. That's not what we want to do. And of course, here we are in our recording step. If we just sent our note on, there's nothing else we're going to do now. We return. If we get to here, then if current time is greater than note off time, in other words, if it's past this time, then we send our note off message. Now, in fact, we keep on sending our note off message, but that is not a problem for our synthesizer. Once the note off has been sent, it doesn't seem to object to receiving more. If for some reason your synthesizer wouldn't like to be sent more note off messages, then you'd probably have to do the similar. You'd have to create a new flag and do what we do in this case. I'm not doing that because it doesn't seem to matter to my Kawai synth. If also the current time is greater than stop record time, in other words, if we've already got to here, then all we're going to do is hit recorder, end record. Now, at this point, we're no longer in our record mode, and the minim audio recorder library is already now going to go off and save that file to disk, or perhaps it was already saving it to disk, but it's going to close the recording session there. We set our gap flag. Now, gap flag is basically just to add a little bit of a gap around here before we start the next one. We don't want to start the next one too quickly. This is something I'm actually counting down. The gap flag I'm actually counting down in frames. So we just set the gap flag back to this value, this constant gap here. Possibly I'm overdoing it. I'm being way too cautious there. And then if the current note is greater than the stop note, in other words, if we've reached the top of the number of notes we're recording, all I do is literally call the shutdown method, and the shutdown method is just going to shut the whole thing down. In fact, that's our method. You'll see that in a second. So in other words, while we're recording, if we were still here, nothing's going to happen. If we get to this point, we send our note on, we trigger our flag, and we just return. If we get past this point, we send our note off message, and now we're just recording the release. The release phase of the sound on the synthesizer. And if its current time is greater than the stop record time, we've passed this. We just stop the recording, and we set this extra flag. And in fact, if we've reached the very top, we've gone through all of the notes, we call the shutdown method. So, shouldn't really be hard. There's a little complexity in this sequencing, but it's not hugely complicated, let's say. Okay, if we weren't currently recording, we're going to do the non-recording step. So we're not currently recording if we're basically between recordings. So, then we just say we're not recording. If the gap flag, which is our sort of countdown in terms of extra frames between this point and this point, is still greater than 0, we just subtract 1 from it. Otherwise, we increment our current notes. In other words, we go on to the next note, and we call this start next, which was the whole initialization of the whole thing. Okay, so that's fairly simple. And finally, shutdown, which is what happens if we've gone over our thing. We just tell the DecentBuilder object to write, and we exit the program. So that's it. You set this running. We set this program running. The important thing is this line here, creating our new example, our new SampleRobot. We're giving all these parameters to it. If you remember, the parameters are things like velocity, start note, how many octaves up we're going, what step, number of notes we're going up, and these in milliseconds, so this is the time of the note on time. In this particular case, I was recording a 2 second of note on and 5 seconds altogether. In other words, there was 2 seconds with the note on, and after the note off, another 3 seconds of the release. This happens because I was playing a slightly longer sax one for this. Normally for a more percussive sound, you'd probably have shorter values here. And then we just create in this draw, we're just basically stepping through, and then we draw a picture of the wave on the screen as well. That's coming directly from the in. So that's nothing to do with our sampling robot, that's just part of the standard audio input that comes with Minim. So the only other thing to understand then is how this DecentBuilder, what's going on inside this DecentBuilder. Now that, I admit I wrote a slightly complicated one. I decided not to use a standard library for XML because there isn't one in the kind of libraries that you get with I couldn't find an XML library here, not one that was just for doing XML in general. XML is always a pain to generate. You know, you want to make sure things are balanced, so I did a slightly weird code that just is convenient for me to balance the tags. Right, so inside my DecentBuilder I just have a string called value, and it's got a file name. When you create a new one, it sets the file name to that. That's the name of this file itself it's going to save. Inside this I have the value variable. Basically, in order to make sure my tags, my XML tags, you can see here, let's say groups, sample, all of this block here has to be inside a group, and that has to be inside of groups, and that all has to be inside the Decent Sampler tag. So I have a little function or method here called wrap. Basically, you give it the name of a tag called T, you give it some extra that's used if you're sending any extra classes to it, etc. And what it does is it takes the existing value currently inside the DecentBuilder and it adds a tag of name T with the extra on the front of it, and it adds a closing tag of the same name on the end of it, and it just returns the object again. So what it means is we can, well, you'll see how that wrap gets used. Like here, we can just say wrap the whole thing currently, the value in currently in group. We wrap it again in groups. We wrap it again in Decent Sampler plugin version, like that. So this line here takes whatever is the sort of inner body of our thing and wraps these around it in the right way. I wrote it like that because I like to write something that keeps my tags balanced, maybe a bit convoluted for a simple example like this, but I figure it will be useful if we get more complex. Possibly I have to change it if we get more complex. There's also this add sample line. This is at the beginning. If you remember, we call that at the beginning of our recording step. If we're in our note on time, if we're sending our note on, we're also adding the sample line. Perhaps that could be done at a different time, actually. I'm thinking about it now. I won't mess with it now, but in a minute I'll experiment with putting it in the start next. It would be better off putting it there. But yeah, when we add the sample line, all we're doing is taking our inner value and appending to it a new line of the format of one of these. The full file is just the entire contents of the file. It just adds this header on the top and then does this wrapping. There's a method called write that then calculates the final value for value. And then processing doesn't have a way of just writing strings into a single file. For some reason, it's got to save strings, which writes an array into a file. And so I have to take the value and I have to actually put it into a one element array. That's not very important, but this will, right? So at the time you create one of these, we're just going to keep adding the sample lines to it, and when we hit the write method, which happens, if you remember, in the shutdown, that's the point in which we calculate this. We wrap all the inner stuff with all the extra tags we need and save it out to a file. So that's just what we have to ensure happens at the end. And that's it. That's really all the SampleRobot does. That's how it works. And I will make it available. So the last thing to remember is that I was taking the files generated from that program, and I was using this quick macro within Audacity to turn the stereo into mono, truncate the silence off the front, export as WAV again. You may not need this. I moved them from stereo to mono because I couldn't get direct wave to read them in as stereo files. It was just blowing up on me. Could be some other problem. I wasn't sure what was going on there. Possibly with Decent Sampler that isn't an issue. Decent Sampler really does seem to be a decent sampler, and it does seem to be working. So, and like I've said, we can use that in any DAW, so that's a good thing. I've been working a bit more on that sound. All the sounds apart from the percussion sounds you're hearing now are from that K1 keyboard. It's kind of funny because it's like, you know, music I would make 20, 30 years ago. This is the acoustic bass preset of the K1. It's quite a nice sound. Didn't sample it quite long enough. Yeah, I don't know what I'm going to do with that. I like a lot of it. I think I want to work on it, build it into something real. But yeah, so thanks for watching. This has been another long one, but we covered a lot of ground, and I hope that's been interesting. I hope it's been useful, and I will try and make that code available. I'm going to figure out where to put it, and the nice thing is now if you've got any old keyboards, you can now grab them quite quickly and easily, and so you can build up your own sample bank. So obviously I've been adding some extra effects to a lot of those sounds. There's not a lot of movement in that particular Kawai synth, you know. I mean, possibly you could program it to have more movement in the sounds. I was not really very aware of that when I used to use it, but I'm glad I've kind of got those sounds now into FL Studio. And obviously any other instruments I get my hands on I can sample pretty quickly as well. So enjoy, thanks for watching, and I will be back soon with another one. Synth Media, and I'm out.